Equations that contain decimals. We're going to clear the decimals by multiplying through by a power of 10. We'll use the power of 10 that has as many zeros as our longest decimal, and that means digits after the decimal. So for the equation below, 0.7x plus 0.1 equals 1.5. We can use 10 because 10 has one zero and the longest decimal only has one digit after it. So we'll multiply everything by 10. I usually just write it right on the equation because it's going to slide the decimal to the right, one place for one zero. So this will give us 7x plus 1 equals 15. And then we have a regular linear equation to solve. So we isolate the variable. The decimals are cleared out. So we would work on the side with the x, and first we would take off the 1. It's added, so we're going to subtract it from both sides. Clean up. 7x equals 14. And then back on this side with x, you're going to divide by 7. So we get x equals 2. Let's look at this equation. This time we will need to use 100 because some of our numbers have 2 digits after the decimal. Remember, we have to go for the longest one. Our first one only has 1 digit after. This one has 2, 1, and 2. So we need 100 with 2 zeros for the 2 digits. You do have to use the same thing all the way across for it to be okay. So my 2 zeros are going to move my decimal 2 places to the right. So my first term will give me 90x. My next one will give 265 equals, this will give 50x. And 545. So you can see the drawback when you have to multiply by 100, the numbers get very large, but it did clear our decimals out. From here we have a regular linear equation. We will isolate the variable. We do have x on both sides, so we need to get rid of one of the x terms. I would probably choose to get rid of the 50x. This is a nice step to learn to do in your head because it's so much writing. So if I have a positive 50x to make it cancel, I need to subtract 50x from both sides. So 90 minus 50 will give me 40x plus 265 equals 545. This 50x is gone, it canceled. Now I'm going to isolate the x, so I need to get rid of the 265. It's added, so I'm going to take it away from both sides. Your equals should always come straight down. If I took it away on the left, it also has to come off of the right. The left, it will cancel out. That was our plan. And we'll subtract here. Now we're ready to divide. So we're going to divide on both sides by 40. This side will cancel to leave us just x. On the right-hand side, if you like, you could reduce first by a factor of 10. That would give us a smaller number to divide. 4 into 28 will go 7 times. So we get x equals 7. Let's look at one more example. For this equation, we could use a 10 to clear out the decimal. Our longest decimal has only one digit after the decimal. So we'll use a 10. We do have to use it all the way across. So 10, 10, 10. And it will move our decimal to the right one space for 1 0. So this will give us 20, or you can do just 10 times 2. That's 20x minus, and this will give us 42 equals 86. Now we have an equation without decimals. So we're going to isolate the x term. We need to get rid of the 42 first. It's subtracted, so to make it cancel, we should add a 42 on both sides. So this is what we had, and we're going to add 42 to both sides. Our equals is coming straight down. On the left, adding the 42 canceled. We're cleaning up. So we have 20x equals, and we'll combine on the right-hand side to get 128. Now we're ready to divide. So we're going to divide on both sides by 20. And this doesn't look like it's going to go evenly, so we'll do a long division. Or we could reduce. We have some options of how to leave our answer. I'm going to divide and go with a decimal since there were decimals in my problem originally. I would also accept a fraction if you reduced. So if we do 20 into 128, we could go 6 times, would give us 120. Subtract, we'll add a decimal, take it up, and we can add a 0. That will give us 4. So x equals 6.4.